Hello my dear students, let us continue our discussion of the type integration by parts. In this module, let's see an interesting question. The question says, evaluate the integral x upon 1 minus sine 2x dx. Now we know the very first step, and that's copying the question. Now my dear students, let me copy the question again, because as of now I don't know what to do in the sum. Now if I remember very clearly from standard 11, I know the method now. And the method is, we need to multiply divide by the conjugate. Now we have seen in standard 11 that whenever 1 plus minus sine x is there in the denominator, we should multiply by conjugate so as to convert the denominator into a single term. That's what we are going to do here. Multiply divide by 1 plus sine 2x in the integral. Now the numerator will look like x into bracket 1 plus sine 2x upon 1 minus sine 2x into 1 plus sine 2x is 1 minus sine square 2x. Now what to do with this? Let's copy the step to understand better. Now my dear students, what I have in the denominator is 1 minus sine square 2x. My 10th standard tells me it is nothing but cos square 2x. That is, I have a single term in the denominator. And I have told you so many times in the chapter, whenever we have a single term, what we need to do is separate the terms in the numerator. So in the next step, we can write the integral as equal to x into 1 upon cos square 2x plus 1 upon cos 2x into sine 2x upon cos 2x dx. That can be written as x into sec square 2x plus sec 2x into tan 2x dx. Now what we have to do is open the brackets. So what we get is integral of x into sec square 2x dx plus integral of x into sec 2x tan 2x dx. Now both of them I need to apply u into v rule. Writing it together may become little difficult. So what we'll do here is assume there's an integral I1 and I2. So we'll assume this as integral I1 and I2. Now let's take one integral at a time. So let's take I1, which is x sec square 2x dx. Now my dear students, x is algebraic, sec square 2x is trigonometric. As per the Liet rule, can I say x will be taken as u and sec square 2x will be taken as v, and we are going to apply u into v rule. So as per the rule, what I'll have is x into integral sec square 2x dx minus integral of d by dx of x, integral of sec square 2x dx, the whole dx. Is that okay? Now my dear students, let's apply the formula. Integral of sec square 2x, can I say it is nothing but tan 2x upon 2. Because coefficient of x is 2, we divide by 2. So minus integral of d by dx of x, that is nothing but integral of 1 into, can I say again the same, tan 2x by 2. Yes my dear students. Now let's rewrite this as x by 2 tan 2x minus of 1 by 2 outside the integral and integral of tan 2x dx. So let's rewrite this as minus 1 by 2 as it is. Integral tan 2x, can I say log mod of sec 2x by 2, because again the same coefficient of x is 2, and since integration is over, a plus c1. Now the two terms in the denominator are 2 and 2. So that is, I can multiply and write a single term, that's minus of 1 by 4 log mod of sec 2x plus c1. This is integral I1. Let's find out the integral I2 on the same lines. So very quickly, if I tell you, the two functions are algebraic and trigonometric, and so therefore x will be taken as u and sec 2x tan 2x will be taken as v. So let's apply the rule. So what we get is x integral sec 2x tan 2x dx minus integral d by dx of x into integral sec 2x tan 2x dx, the whole dx. My dear students, let's apply the formula. Now integral of sec x tan x is sec x, so in this case I'll write sec 2x by 2 minus integral of d by dx of x is 1 and the same sec 2x by 2 dx. So let's rewrite this as x by 2 sec 2x minus 1 by 2 integral sec 2x dx. So that's x by 2 sec 2x as it is, minus 1 by 2 as it is, and integral of sec 2x is log mod of sec 2x plus tan 2x by 2 and plus a c2. Again we'll rewrite this as 1 by 4, 2 and 2 get multiplied. I1 is over, I2 is over. Let's write the final answer. I was assumed to be equal to I1 plus I2. let's write the values of I1 and I2 respectively. So these are the values which we obtain for I1 and I2. Now my dear students, I can simplify this by taking some terms common. If you observe, there are two terms which have x by 2. So let's take x by 2 common to get tan 2x plus sec 2x along with it. And likewise, a minus 1 by 4 is common to the remaining two terms. So a minus 1 by 4 log mod of sec 2x into sec 2x plus tan 2x plus c, where c is nothing but c1 plus c2. And that's your final answer for this particular sum. On the same lines, my dear students, I want you to try this particular question wherein you will multiply by 1 minus sin x to the numerator and denominator. That's all I have in this module. Thank you very much.